what we have here is a real-world Rust project that we're gonna build a container for, and we're gonna be using Distroless. First, let's walk through some of the code that, like, one of the reasoning behind this project, and it's a Distroless API that we're gonna be using. So effectively what we're trying to do here is trying to have an API that will be using tokenizers. At the top you can see that I am using that crate. So what we're trying to do is we're creating a generic function here, and that generic function takes a string, well, actually two strings. One is the name of the pre-trained from the pre-trained tokenizer and the actual tokenization. So if I scroll here to the tokenization function, we're going to accept a post request to tokenizers. You can see here this is generic, so any pre-trained, I call it pre-trained model here, or this calls it pre-trained model, but I think it's from a pre-trained tokenizer that we have available. So say for example bird case uncased, then or bird base uncased, all of those will be available here, and then we'll try to work with those. So those are implementation deals. They're not, these details are not that important. What we're trying to do is we're working with Rust. We're using Actix Web. It's going to run and bind to any address and on port 8000, and then we're going to interact with it. So that's it. I'm not going deep into the details of what's in the application itself. What we're trying to do is seeing how Distroless can work for us. So let's go to the most important portion here, which is Dockerfile. Effectively, you are going to be able to apply these techniques on Distroless and then make them work on your own use case. So I'm going to start by using the Rust 1.67 Buster image. Buster is the Debian image. This 1.67 is the Rust version, and I am assigning that that origin, that base distribution, that image as the builder. So this becomes essentially a variable. So builder is the variable. Then I change the working directory to user source app and copy all of the contents from the repository, then do a normal build release. And now, so far, all the way, everything from here, that's kind of like what you would have when you're building or creating an image, a container, using regular Docker. No problem, with the one slight addition of getting this as a variable. So we're calling that as builder. Then the magical Distroless portion happens here, and it's 3 lines. So we'll see how this is actually possible. And what we're doing is we're finding our Rust, or the Distroless image that we're gonna be putting our Rust application in there. In this case is Debian 10, and that is fine. And there's plenty more. These are all coming from the Google Container Registry. That's what gcr.io stands for. That's the domain for the Google Container Registry, and you can see that's Distroless. And then what we're gonna do is we're going to copy the resulting binary, which in my case is going to be rust-tokenizers-API, and I'm going to copy that and I'm going to put it in user local bin rust tokenizers API. And then the command, if I run that container, is going to be the name of the actual the resulting binary. So that's one of the powerful things that Rust has, is that you can end up with a binary and then you can put it somewhere else, and we'll see how that works. So I've switched to VS Code here, and I'm going to run the terminal, and I'm going to make a couple of changes. So this is the same project, same files, everything the same as before. I'm going to remove that to make this view better, and I am going to run Docker build. So I'm going to say, let's see, Docker build, and the context is the current directory, and I am going to tag these as, I'm going to say, Rust local, or how about local and then Distroless, and I'm going to tag it like that, and I'm going to run that command, and this is going to start pulling all of the layers, all of the images, and it will take about 5 to 6 minutes, depending on your bandwidth, you might get different results. So let's just wait until this completes, and then we'll come back to play around with that resulting binary, that resulting Docker image, Docker container that we built. All right, so we've finished building this container image. Now let's take a look at the images that we have here. So I'm going to try to find it out with Docker images, and then I'm going to grep for Rust. I'm going to filter that result by local Distroless and see what the result is. So there you go. That's the image, and this is tremendous. It is 36 megabytes, which is absolutely stunning. It is really amazing that something can be weight essentially 36, only 36 megabytes. And what we can do here is we can actually try to run it. So I'm going to clear here, and I'm going to run the command that would make everything work. So in this case, it's going to be Docker run, and then IT for making it interactive. I don't want that to go in the background. And then I'm going to map the ports 8000 on the container. I want that mapped locally on my machine. And then this is the tag that we use. So I'm going to run this and get to see what happens. All right, so pretty fast. Atix started the process. It is actually running. And if we go very quickly to the Explorer, and then we look at source and main.rs, you will see that we're exposing these tokenizers pre-tamed model, and we'll need to send something. If we look at the serializer, it's text and then string, so we'll need to send some JSON for sure. Okay, so I've opened up a new terminal, and what I'm going to do, I'm going to paste the command that I'm going to use. It's going to be curl to send a post request. I'm going to send some data. The data is going to be text is the key, is JSON. The value is going to be some text. The header is going to be content type application JSON. And then the local host, here we need to add tokenizers. And then how about BERT base uncased, which is one of them. And then what we get in return should be the tokens that have been, the text that has been tokenized. And we could do the same if we wanted for some other tokenizer as well. So there you go. That is basically how we have this running. It is in a container. If I switch back to Docker, you'll see all of the requests that happen, and we are seeing the bird base cased and uncased tokenizers. And the most critical thing here is that only with some minor tweaks to your Dockerfile, you can have something that is 36 megabytes, unlike something that will be hundreds of megabytes, or perhaps more than 1 gigabyte, or perhaps even 2 gigabytes of a container size image. This will allow you to get faster deployments, easier rollouts, and faster experimentation when you're trying to run your Rust application from a binary.